Hello there, Mr. Sutton here, bringing you the IM3 Honors 4-1 Part 1 homework solutions on solving quadratics by factoring. To solve this equation by factoring, we first need to get everything on one side of the equation. So let's start by subtracting this 8n to the left side. That gives me n squared minus 8n equals 0. And at this point, I see that I have two terms, both of which have an n in them. So I can take out a common factor of n. And then inside my parentheses, I'll have n minus, this becomes 8. And now setting each of these two factors equal to 0, if n equals 0, well then n equals 0. And if n minus 8 equals 0, adding 8 would give us an n value of 8. To solve this equation, let me just double check to make sure everything's on one side. It is. So now I can factor this and set each factor equal to 0. So I need factors of negative 28 that add up to negative 3. Well, my choices are 1 and 28, which won't work. 2 and 14 also won't work. But if I had positive 4 and negative 7, that would add up to negative 3. So we can write x plus 4, x minus 7. And then setting each of these equal to 0, we see that x must equal either negative 4 or positive 7 to zero out one of those factors. Before I can solve this equation by factoring, I need to get everything on one side. Let me subtract the 21 to start that process. Now that I've got 0 on the other side, I can factor and set everything equal to 0. So I need factors of negative 21 that add up to negative 4. Well, 1 and 21 is not going to do it. 3 and 7 is the only other choice. If I had positive 3 and negative 7, we could get negative 4 by adding those. So I'll write x plus 3, x minus 7, and all that equals 0. Setting each of these equal to 0 and solving, we see that x equals negative 3 for that first parentheses and 7 for the second one. To solve this by factoring, I have to first subtract 25 from both sides. Now that I've done that, I see that I have something in the form a squared minus b squared, difference of squares. So my factorization is going to be an a plus b, a minus b kind of thing, where I take the square root of each of these and put them in parentheses. So we have an x plus 5, the square root of 25. So x plus 5, and then x minus 5 is the other factor. Setting each of these equal to 0 and solving, we see that x is going to equal negative 5 if I want to zero out that first parentheses, or positive 5 if I want to zero out the second parentheses. For this problem, trying to solve by factoring, we see that our equation is already zeroed out and in standard form, so we just have to factor it now. So I need two numbers that multiply to negative 24 and add up to 5. So factors of 24, we've got 1 and 24, which is not going to work. And how about 2 and 12? Nope, that's not going to work either. 3 and 8, though, shows promise. If we had negative 3 and positive 8, that would add up to 5. So then we can factor this into x minus 3 and x plus 8. And we still have the equal 0. Setting these each equal to 0 now, we see that x values of 3 and negative 8 will zero out each of those parentheses. So those are our answers. To solve this equation by factoring, we need to get everything over on one side. I have to move this 16x over here to the left side. So if I subtract 16x, that's going to give me x squared minus 16x plus 64 equals 0. And at this point, since I just have a normal x squared here, 1x squared, I can just go ahead and factor this. So I need factors of 64 that add up to 16. Now you might actually recognize that x squared and 64 are both perfect squares, so we might be able to use that a minus b squared shortcut. Square root of x squared is x, the square root of 64 is 8, and if this works, we would have an x minus 8 because of this negative middle term, x minus 8 squared. And let's just multiply these together and double it to make sure that we get negative 16. So 2 times x times negative 8 does give us negative 16, so this is actually the factorization. And now setting x minus 8 equal to 0, because we have two factors of x minus 8 that are both exactly the same. So setting just one of those equal to 0, we see that an x value of 8 will zero out this equation. To solve this equation by factoring, I have to subtract that 9 to the left side so that I have 0 on one side. And now I see that I actually have something in a squared minus b squared format here. So I can use my plus minus shortcut. Taking the square root of each of these things, we've got p plus 3 and then p minus 3. So if that all equals 0, at this point I can just set each parentheses equal to 0 and solve. So that gives me p-values of -3 for that first parentheses, and a p-value of +3 will zero out that second parentheses. On this problem, I'm given that s minus 3 quantity squared is 0, and I want the value of s plus 3 times s plus 5. Well, my first task is to figure out the value of s, and then I'll plug it into this expression over here. So if s minus 3 squared equals 0, that means that s minus 3 all by itself must have a value of 0, right? Because if you square 0, then you're still going to get 0. So if s minus 3 equals 0, that means s must have a value of 3. And if s equals 3, I can rewrite this expression they gave me as 3 plus 3 times 3 plus 5. So that's a value of 6 times 8, which gives me 48 for the product, and that's going to be answer choice A. On this problem, we want to know by how much does the sum of the roots of this equation exceed its product of its roots. So first we have to find the roots. Since this is already factored with 0 on the other side, we just need to figure out what zeroes out each of these factors, because if you zero out one of these things that's being multiplied, you zero out the whole side there. So for this first factor, if we have a value of x equals -1, that would zero out that first parentheses and solve the equation. And for the second parentheses, we need x equals +3, because 3 minus 3 is 0. All right, so now we need to compare the sum and the product of the roots here. So for the sum, we've got -1 plus 3, which is +2. And for the product, we have -1 times 3, which is -3. And if we want to know how much bigger the sum is than the product, we just have to do the sum, which is 2, minus the product, which is -3. Well, 2 minus -3 really means 2 plus 3, so that's a value of 5, and that is answer choice D.